In July 1994, astronomers watched a comet break apart and slam into Jupiter, piece by piece, in the most direct proof we've ever seen of the planet's gravitational muscle. The comet was Shoemaker-Levy 9, discovered in 1993, already torn into more than 20 separate fragments by Jupiter's gravity during an earlier close pass, then pulled back in on a collision course over several days in July 1994. Telescopes around the world, along with the newly repaired Hubble Space Telescope, watched each fragment slam into Jupiter's atmosphere at roughly 134,000 miles per hour, one after another, leaving dark impact scars in the clouds larger than Earth itself, visible through backyard telescopes for months afterward. Astronomers had never before been able to predict, observe, and study a cosmic collision of this scale in advance, making it a landmark moment for planetary science. Jupiter is by far the most massive planet in the solar system, more than twice the combined mass of every other planet put together. That enormous mass gives it an outsized gravitational pull, capable of nudging, capturing, or violently flinging distant comets and asteroids that happen to pass anywhere near it. For decades, this led to a popular idea repeated across textbooks and documentaries, that Jupiter acts like a cosmic vacuum cleaner, quietly absorbing objects that might otherwise eventually threaten Earth. Even asteroids in the main asteroid belt sometimes get nudged by Jupiter's gravity into new paths that occasionally send them toward the inner solar system instead of away from it. More recent computer simulations have complicated that simple, comforting story considerably. While Jupiter does capture and eject plenty of small bodies over long time scales, some research suggests its gravity also flings certain objects into brand new orbits that end up crossing Earth's own path, meaning it isn't purely a protective shield after all. Researchers now generally describe Jupiter's overall net effect on Earth's long-term impact risk as real, but far more mixed and complicated than the popular vacuum cleaner idea originally suggested. What Shoemaker-Levy 9 proved beyond any doubt is that these impacts genuinely happen, and happen with tremendous, planet-scarring force, on planetary scales, within our own solar system, within living human memory and full scientific documentation. It remains one of the clearest real-world reminders of why planetary defense, the ongoing work of tracking and understanding near-Earth objects, has become a serious, funded field of astronomy today rather than a purely hypothetical concern for the future. Survey telescopes now scan the sky nightly, specifically looking for objects on a possible collision course, a direct legacy of the lessons learned from Jupiter's dramatic 1994 impact. Subscribe for more real events that shaped how we watch the sky.